Welcome to another exciting episode of Spelling Bee Ninja. Today, we are diving into the fascinating world of energy and electricity. We'll explore everything from the types of energy we encounter in our daily lives to the fundamental principles of electricity that keep our devices running. Whether you're a science enthusiast or just curious about how things work, this lesson is for you. So, sit back and let's light up our minds with knowledge about energy and electricity. Energy is all around us, and it plays a crucial role in everything we do. At its core, energy is defined as the ability to do work or cause change. It exists in various forms, which we encounter in our everyday lives. For instance, kinetic energy is the energy of motion. Think about a moving car or a rolling ball. That's kinetic energy in action. On the other hand, potential energy is stored energy, like food waiting to be eaten or water stored in a dam. Along with these, we also have thermal energy, which relates to heat, chemical energy found in food and batteries, electrical energy that powers our devices, nuclear energy from the core of atoms, and light energy, which allows us to see. It's fascinating to note that according to the law of conservation of energy, energy cannot be created or destroyed. It can only change from one form to another. This principle is fundamental in all branches of science. Understanding energy's different forms helps us to harness it more effectively in our lives. For example, when you drop a ball, its potential energy transforms into kinetic energy as it falls. Energy is everywhere, and without it, we would not be able to function or enjoy modern conveniences. Now, let's talk about electricity, which is a specific type of energy. Electricity is essentially the flow of electric charge, typically electrons, through a conductor like a wire. It's this flow that powers our homes and devices. Have you ever wondered how the electricity gets to your light bulb? That's all thanks to electric current, measured in amperes, or amps for short. When we think about the power behind the current, we also must consider voltage, measured in volts. This is the pressure that pushes the electric charge through the wires. Resistance, measured in ohms, is what opposes the current flow. Ohm's law gives us a simple equation that connects these three elements: voltage equals current multiplied by resistance. Understanding this relationship is vital for anyone interested in electronics or building their own circuits. Speaking of circuits, let's explore how they work. In a series circuit, all components are connected end-to-end, meaning that the electric current flows through each component in turn. If one component in this series fails, the entire circuit will stop working. On the other hand, a parallel circuit connects components in branches, allowing the current to split across different pathways. If one branch fails, the others continue to work, which is how household wiring operates. This clever design means that if one light goes out, the others stay lit, making our lives more convenient. Now, let's shift gears to renewable and non-renewable energy sources. Renewable energy comes from natural sources that can be replenished, such as sunlight, wind, or flowing water. These sources are considered cleaner and have less impact on our environment. For example, solar panels convert sunlight into electrical energy, while wind turbines harness wind flow. On the flip side, non-renewable energy comes from sources that are limited, like fossil fuels, including coal, oil, and natural gas. Though these fuels are currently used extensively for energy production, their depletion poses a significant challenge while contributing to pollution and climate change. It's crucial to understand the difference between these two energy types, as the future of energy heavily relies on developing cleaner alternatives to sustain our planet. Another important concept in electricity is the role of batteries. A battery is a device that stores chemical energy and converts it into electrical energy through electrochemical reactions. This process allows us to power everything from our mobile phones to electric vehicles. The first battery, known as the voltaic pile, was invented in 1800 by Alessandro Volta. Today, we often use lithium-ion batteries, which are rechargeable and very efficient for modern technology. Did you know that the world's largest battery isn't a single unit? It's actually a pumped hydro storage facility that can generate a staggering amount of electricity. When demand is low, water is pumped to a higher reservoir, and it is then released to generate electricity when needed, showcasing a fascinating aspect of energy storage and peak demand management. Now, let's connect electricity and magnetism. Magnetism is a force that can attract or repel materials like iron, nickel, and cobalt. When electric current flows through a wire, it produces a magnetic field, which was discovered by Hans Christian Ørsted in 1820. Conversely, a changing magnetic field can induce an electric current, which is the principle behind how generators work. This relationship between electricity and magnetism is known as electromagnetism and is the foundation for many everyday devices, including motors, generators, and even speakers. Speaking of devices, a generator is a machine that converts mechanical energy into electrical energy using electromagnetic induction, while a motor does the opposite, it turns electrical energy into mechanical energy. Both devices are essential in our daily lives. Generators are commonly used in power plants, and motors can be found in appliances from washing machines to electric cars. Understanding how these devices function allows us to appreciate the technology we often take for granted. Safety is another critical aspect when dealing with electricity. Practicing electrical safety helps to prevent accidents such as shocks, fires, and electrocution. Simple measures like not using electrical devices with wet hands, not overloading outlets, and unplugging appliances for repairs can significantly reduce risks. Additionally, ground fault circuit interrupters, or GFCI, play an essential role in protecting us from electric shock. They automatically shut off power if they detect an imbalance in the current, such as when touching a live wire. Staying aware and following safety measures are crucial for keeping ourselves and others safe from electrical hazards. Finally, let's wrap up our exploration by discussing energy efficiency and conservation. Energy efficiency means using less energy to perform the same task. For example, LED bulbs require significantly less energy to produce the same amount of light as incandescent bulbs. On the other hand, energy conservation refers to changing behavior to reduce energy use. Simple actions like turning off lights when leaving a room, using public transport, or adjusting your thermostat can go a long way. Being mindful about our energy use can help us all contribute to a more sustainable future. As we move forward, the future of energy is leaning towards cleaner, renewable sources. Solar and wind energy are advancing and becoming more affordable, leading to a rise in electric vehicles. Innovations like smart grids are enhancing how we manage electricity demand using technology, and battery storage solutions are becoming crucial for utilizing renewable sources effectively. However, challenges still lie ahead, especially in energy storage and managing our transition from traditional sources. Understanding these concepts and remaining curious about energy and electricity not only broadens our knowledge but empowers us to make informed decisions about energy use in our lives and the future of our planet. To sum up, we've taken a close look at the world of energy and electricity today. We explored various forms of energy, the essential principles of electricity, and their interconnectedness found in circuits, batteries, and safety measures. We've discussed the differences between renewable and non-renewable energy sources and the technology we use to convert, store, and manage energy. The importance of energy efficiency and safety cannot be overstated, as they play a vital role in our everyday lives. Through understanding these concepts, we can all contribute to a greener, more sustainable future. Thank you for joining us on this enlightening journey into energy and electricity. We hope you enjoyed learning about these essential topics and how they influence our world. Keep exploring, stay curious, and remember, every small step toward understanding and conservation counts. Join us next time for more fascinating science lessons here on Spelling Bee Ninja.